In this video, we're going to apply the ratio test to find out the interval of convergence for sine of x, whose Taylor series is given by n equals 0 to infinity of negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. I'm going to go right into applying the ratio tests. So limit as n goes to infinity of x to the n plus 1, and it's an absolute value, so you don't need to worry about the alternating piece. And so x to the 2. Now remember, you're putting in n plus 1 for n, so it's a good habit to put in parentheses, because I see people just add 1 onto the n and it'll mess up your canceling. So 2 times n plus 1 factorial. And instead of dividing by a sub n, I like to just think of it as multiplying by the reciprocal, because I'm going to be looking for canceling anyways. So that just kind of cuts out a step for me. Alright, let's rewrite these, simplify all the parentheses, and then we'll start to look at what we can factor and cancel. So this is going to be 2n plus 2 plus another 1, so that's going to be a 2n plus 3. So x to the 2n plus 3 here, over 2n plus 3 factorial times 2n plus 1 factorial over x to the 2n plus 1. Alright, so we get the limit as n goes to infinity. Now we're going to look to see what will factor. Now for instance, this is basically 2n plus 3 x's multiplied together. So I can rewrite that as x to the 2n plus 1 and times x squared. So I'm splitting off two of them to make it match up with this term here. I'm going to do something similar here. I'm going to start to write out the product of this factorial, so 2n plus 3 times 2n plus 2, and I'm going to stop there and write the rest as 2n plus 1 factorial. Once again, to match up with this 2n plus 1 factorial here, and x to the 2n plus 1. Now, I can clearly see my canceling. Now I'm going to pull out the x squared, and I no longer need the absolute value because x squared is always going to be positive, so I'm not worried about that. And the only part that depends on n, limit as n goes to infinity of 1 over 2n plus 3 times 2n plus 2. And I can see I've got 1 over basically something that's going to infinity, which means this equals 0, which means it's always going to be less than 1. This is our favorite case. This means we have a radius of convergence of infinity, and our interval of convergence is negative infinity to infinity, which means this Taylor series converges for all values of x.